Hello everyone, today let's solve the problem number 48, rotate image. So what the question states here, we are given an n into n matrix representing an image. Again I'm telling, we have been given an n into n matrix representing an image. So we have to rotate this one, we have to rotate the matrix 90 degrees clockwise in place, right? So they have strictly mentioned in place here. So we have to rotate the matrix 90 degrees clockwise in place without using any extra 2D matrix. They have clearly mentioned here. So just keep this in mind. We shouldn't use any extra 2D matrix. We have to modify only in place. Means we have to rotate the matrix 90-degree clockwise in place. So in place word matters a lot here, right? So this is the main thing. So let's come to the first example here in this case. So just give me a second here. So yeah, here you can clearly see we have 1, 2, 3, 4, 5, 6, and 7, 8, 9. So when we have to first, what we have to do, we have to rotate this one 90 degree, right? In this case, when we rotate this one, 741 comes to the first row. So this one comes to the first row, you can clearly see here 741, we are rotating this one, and 852 comes to the second row when we rotate 90 degrees. So 852 comes to the second row, and the finally same thing here, 963 comes to the third or the final row here in this case, right? So from bottom to top, so 963, this one I'm speaking of, 963, right? So this comes at the last row. So that's what we need to do here, right? This is simple to understand. So let's consider the second example here. I'll just come here in this case. So we have 5, 1, 9, 11, 2, 4, 8, 10 as the second row, 13, 3, 6, 7, 15, 14, 12 and 16. So here first row, we will consider 15, 13, 2 and 5 as the first row here, right? Same goes with the second, third and fourth as well. 14, 3, 4, 1, 12, 6, 8, 9, and this one 16, 7, 10, 11. So rotating 90 degree is not a big deal, so we have to do that, but they have asked us to do one thing. We have to rotate it 90 degree clockwise in place. So that one we need to keep in mind. Basically, we shouldn't be using any extra 2D matrix. We have to modify in place. Just keep this in mind. 12, 6, 8, 9, and finally this one 16, 7, 10, 11, right? So this is fine. So that's what we need to return in the form of output 15, 13. After rotation, 90 degree rotation, we have to modify and we have to return the output. So in this case, we have in the first row 15, 13, 2, 5. Same thing goes for the second one. Second row 14, 3, 4, 1, 12, 6, 8, 9, and finally 16, 7, 10, 11. Right? This is fine. So I hope question is completely clear. This one, whatever the examples that we discussed in, completely clear as well. They have given us wonderful examples just for the sake of understanding, right? So this is fine. So I hope the question is completely clear as well. So first, let's discuss the approach, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So the first thing that we need to keep in mind here is we are going for the in-place rotation, right? We are going with the in-place rotation approach. Nothing but we will transpose first, plus we will reverse the rows. We will first transpose and then we will reverse rows. So this is the approach basically we'll be going with. In short, we can just call this one in place rotation, right? So I have considered the first example, the same first example that they have given in the question. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have already discussed this one. While we rotate this one 90 degree, then we'll get the answer 741, 852 and 963. We have already discussed this one, right? So let's move on with the this one step by step execution. So here the same example, let's go with the step 1 here. Transpose the matrix. First, what we will do, transpose, and what we will do here, we are going with the approach transpose. Then after transposing the matrix, we will go with the reversing the rows, right? So first one, we will transpose the matrix. We will swap matrix of ij with matrix of ji for all I less than j, basically, right? First thing here is, first we had 1, 2, 3, 4, 5, 6 and 7, 8, 9. 1, 2, 3, 4, 5, 6 and 7, 8, 9, right? So after transposing, what happens here, we got 147, this one 147, 258 and 369, right? So we got 147, this one 258 and 369 after transposing. So we are just swapping here, right? We are considering 147. First column we are putting into the first row, the second this one second column we are putting it to the second row, and the third column, this one second column, and the first column, third column we are putting it to the third row here, 369. I hope this is clear, easy to understand, right? Let's move on with the second this one second step. So what we are doing after transposing, we have to reverse the rows, right? After transposing we have to reverse the rows, right? So now we will reverse each row in place. We will reverse each row in place. Means here in this case, when I say we will reverse each row in place, we had here 147, 258 and 369, right? Let's reverse the same here in this case. So when we reverse this one 147, just reverse. So here 147 will become 741 basically, right? 258, let's reverse the second row here in this case. When we reverse the second row, 258 becomes 852, right? When we reverse the third row, this 369 becomes 963. So this will be 963. So the output after reversing that we need to get here is 741, 852, 963, right? Let me come here so you can clearly see here 741, 852, 963. So now reverse each row in place. After reversing what we got here in this case, this one. So we have clearly discussed this one, right? So this is same as the output that they have given for the output that we got here as this one, right? 741, 852 and 963. So of first what we did, we went for the transpose, right? First we went with the transpose, then we reversed the rows in place, nothing but we reversed each row, transpose and reverse, that's it. So the output that we got here is 741, 852 and 963, which is equivalent to the output that they have given for the first question, first example in the question, 741, 852, 963. You can clearly see here 741, 852 and 963. I hope this is completely clear, right? Again, I'm telling the output that we got is equivalent to the output that they have given for the first example in the question. So approach works absolutely correct in this case. So approach works absolutely correct in this case, right? So the approach works absolutely correct in this case. Now, as we are completely familiar with the approach, let's discuss the edge cases very quickly, right? Let's discuss the edge cases very quickly. The first edge case that we went with here is this one. The first edge case that we need to discuss here is 1 into 1 matrix. So when I say 1 into 1 matrix, we have only one element here, so no change here. We don't have to go with any change, as rotation has no effect on a single cell here in this case. So we'll return the same element as output, right? 1. So let's go with the next edge case, or the second edge case here, 2 into 2 matrix. We have 1 comma 2 and 3 comma 4 here. So the output that we got here is 3 comma 1 and 4 comma 2. When I say 3 comma 1 and 4 comma 2, we are going with the rotation that transposes the reverse rows, right? So sorry, we are going with the rotation that transposes, then we are reversing the rows. We know this one, right? We have already discussed this one step by step. So here in this case, the output that we need to get here is 1 2 3 4. First here transpose, so this one we have already discussed this one. You can just try it out in the same way that I showed for this one, by considering the first example in the approach, right? Just try it out. This is simple. We have only two rows basically, 1 2 3 and 4. You can just try it out in the same way. We'll get the output basically 3 comma 1, this one. So let me show here 1 comma 2 and 3 comma 4 we have, right? So first what we will do, transpose. We will consider these first row and first column and second column. What we got here, 1 3 and this one 2 4. After transposing we will reverse this one. When we reverse this one, what we get, 3 1 and 4 2. So this is the output basically, 3 1 and 4 2. So here 3 1 4 2. I have shown this one. This is fine. Let's move on with the third edge case here. In this case, matrix we have here is 5 5. We have all the elements are same, so we can just return the same output, right? So all the elements are same here. After transposing and reversing the matrix, we get here in this case 5 comma 5, 5 comma 5 itself. So let's go with the final edge case or the fourth edge case. Sorry, just give me a second. Yeah, final edge case or the fourth edge case, negative elements. So negative elements, -1 -2 -3 -4. In this case, first what we will do, we will reverse. So when we reverse, we get this -1 -2 -3 -4. We will transpose first, right? This will be -1 -3 -2 -4. So when we rotate this one, what it becomes, minus 3 minus 1 minus 4 minus 2. So this is the output that we got here, right? This one I'm speaking of, minus 3 minus 1 minus 4 minus 2. This is fine. So these are the 4 edge cases that we need to keep in mind here. The first one is for the 1 into 1 matrix, the second one is for 2 into 2 matrix, the third one is for all elements, all same elements, and the fourth one is for the negative elements. So these 4 edge cases that we need to consider here. So I hope approach and edge cases are completely clear. Now, as we are completely familiar with the approach as well as the edge cases, we are good to write the code. Let's start writing the. So the first step here is we have to get the size of the matrix. So I'll just go with, let me assign the length of the matrix here to n basically. Just go with length. This is fine. So the next step is we have to transpose the matrix, right? We have to transpose the matrix and reverse each row. So second step here is let's transpose the matrix first. So I'll just write here for int I equals 0, I less than n. So I plus plus. This is for the rows. For the column, I'll just go with for j equals I, j equals I plus 1 will be going with, right? So I'll just go with j equals I plus 1, j less than n, and let's increment the j here. This is fine. So within the for loop, what we will do, we will save the element at ij. Then let's swap with ji. First let's save the element at ij, then swap the same with ji, right? So that's what we will do. So I'll just let's save the element first. I'll just make use of the temporary variable for saving the element at ij. So I'll just give here matrix of I and j. So after saving the element, we have to swap the element. We are transposing the matrix here, right? So we need to swap with ji. So here matrix of I, j, for swapping what we will do, we will just go with matrix of ji, right? So matrix of ij. Sorry, what did I do here? Just give me a second here. Matrix of ji. This is fine. Then what we have done within the for loop here, we have saved the element at ij by considering the temporary variable. After that, we are swapping with ji, right? So after completing the swap, we have to assign this one to this one, right? So here matrix of I, ji after swapping this one, matrix of ji, we have to assign this one to the temporary variable. So we have successfully completed the swap here. I'll just come out of this for loop entirely, right? So I hope this is clear. This is for the transpose. After transposing, we have to reverse each row, right? So that was the last step. So let's reverse each row. Again, let's go with a simple for loop here. For int I equals 0, I less than n, I plus plus. This is fine for loop. Then let's set the pointers when to the row end, right? So I'll just give here let int left equals 0. So this is fine. And right, we have to initialize this one to the final means last element, right? So last index. So I'll just go with the n minus 1 here. 0 n minus 1, left and right. I hope this is clear. Easy to understand. Let's go with a simple while loop here. While left less than right. So in this case, we have to save the left element within the while loop. First, we need to save the left element. We are reversing, right? We are entirely reversing the row elements. That's it. That's what we need to do. First, let's save the left element here. Again, I'll just make use of the temporary variable. So here in this case, I'll give matrix of I left. This is fine. So after saving the left element, we have to swap with right element, right? We have to swap. We are reversing the each row. Let's save the left element, then swap with the right element. We'll complete the swap, means we will assign that one to the temporary variable, and finally we will move inward. So these are the steps. Simple, right? So let's write the same here. After saving the left element, let's swap with the right element. So this is similar to what we have done here, transposing the matrix, right? So I'll just give here. In this case, we are doing with left and right. So the same thing. Matrix of I, this one with the left. So this one, while we swap, this becomes matrix of left and I. We are just swapping. This is fine. After swapping with the right element, after swapping the left element with the right element, then what we will do, we will complete the swap. Nothing but whatever this swapped here, this one, we will assign this one to the temporary variable. So I'll just give here tmp. So we have completed the swap. After completing the swap, we have to move inward, means we have to increment the left and decrement the right. We have to increment the left and decrement the right. This is the last step basically. So I'll just go with incrementing the left and decrementing the right. So this is it for the code. Simple to understand, right? First, initialization, we are getting the length of the matrix basically. Then we are going with transposing the matrix. Then we are reversing each row step by step. After these three steps, finally we are moving inwards, means we are incrementing the left and decrementing the right. So this is it for the code. Let me hit the run button. I hope this works. What happened? So I have not mentioned int here. You can clearly see line number 6. So let me give int here. This is fine. So let me hit the run button again. I hope this works now. Wrong answer we are getting. Let's check what we have done. So here what mistake I have done here is in the line number 17, we are swapping the left element with the right. We are not swapping the same elements here, I and left. This one I have done wrong basically. So we are swapping the left element with right, means this has to be I right, and same goes with the next line as well. This has to be, so I'll just delete the left here. In this case, it has to be I right. This one we are assigning this one to the temp. So this one I have made a mistake basically. So let me hit the run button. Let's see. This has to work. Let's see. So yeah, now you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed, means the code works absolutely correct on this case, right? So let's quickly discuss the complexities for the code that we have written. So just give me a second here. Yeah, the approach that we went with here is in place rotation, we know, or we can just call this one as transpose plus reverse rows. First we are transposing, then we are reversing the rows, nothing but in place rotation, right? So this is fine. So what would be the time complexity here? We are making use of the nested loops. You can clearly see. I'll just show, just give me a second here. So the overall time complexity would be big of n square here. You can clearly see I'm speaking of the line number 5 and 6, right? So we are making use of the nested loops basically. So when I say nested loops, every element is visited once during the transpose and once during the row reversal, right? So we are visiting every element once during transpose and once during the row reversal. So overall time complexity would be big of n square, quite obviously. And what would be the space complexity here? Overall space complexity would be big of 1. So why it is big of 1 here? Because we are not making use of any extra space at all, right? So we are not making use of any extra space at all. All the operations are in place on the original matrix. We are just modifying the matrix in place. That's it. We are not making use of any extra space at all, right? So the overall space complexity would be quite obviously big of 1. So the time complexity for the code that we have written is big of n square, and the space complexity for the code that we have written is big of 1. So I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.